Good morning, folks. My name is Rohan Dsouza. I'm studying in National College of Ireland, and my topic is optimizing container usage based on load scheduling. So, the whole point of shift of infrastructure from virtual machines to containers was that there was overhead. Now, if you see infrastructure, there's a host OS, there's a hypervisor, then there is a guest OS, and this is where you install your applications on the guest OS. But on the container, you just have your hardware, your host OS, your Docker engine, which is also like a hypervisor, and then you install your applications. You have to not install any guest operating system. So that was where the overhead was seen less in containers. And furthermore, developers used to complain that their code ran on their systems, but it did not run in production. So they used to give this excuse whenever their bugs were found in their code in on the production servers. So Docker can also solve that issue by because it is exporting the library files and the binary files as well to the production system. So Docker is also helping us there, or Docker or containers for that matter. So the problem area was that so to manage Docker containers in whenever you had a cluster of Docker containers, say I have 100 Docker containers, and it became very difficult or it became monotonous to manage all 100 of them, and I had to use something like Kubernetes, or else I have to do manually some. There would be manual intervention that would be required. So Kubernetes helped us solve that issue, or Kubernetes or any other Docker container orchestration tool. But the problem was that these container orchestration tools would cause a significant amount of overhead, and also the load balancing they used to do was using third-party load balancers. So again, that would add to the overhead. Now, this is the architecture of Kubernetes. We see that there is a master node and there are two worker nodes. So you need a minimum of 3 nodes first using Kubernetes. Now you see kubelet, kubeproxy. These are all daemons or Docker containers that are running. etcd. These are all. This etcd is a database. So there's a significant amount of overhead which should not be there. There are many moving parts, and this has nothing installed. This is the most basic setup of Kubernetes. So there's a significant amount of overhead already. Furthermore, now Docker containers have a NAT IP assigned to them by default. So there'll be a 172 IP, a NAT IP. So this Docker container cannot communicate with this Docker container. So we have to use third-party tools like Flannel, which will create an overlay, basically a virtual IP, a virtual network. So it creates a 10 subnet virtual network, so that this container can now communicate with this container. There's no way to do it without using third-party tools like Channel. So the research question was, how can Docker containers auto-scale and load balance without any orchestration tools to reduce overhead? And to what extent can it influence the performance? So the research objective was to eliminate overhead problems caused by container orchestration tools in virtualized container setups, proposing an algorithm to auto-scale and load balance. Okay, so the objective is basically to eliminate the overhead caused by container orchestration tools, and we shall be proposing an algorithm which will not be using any orchestration tools, and load balancing will be done without any third-party applications, hence furthermore reducing overhead. So the proposed solution, this is an algorithm that has been proposed. So we'll be setting up a threshold. So when your CPU utilization or your memory utilization goes beyond that threshold, the containers will auto scale, and once it comes below the threshold, it will get killed. Now it after it gets killed, it will exit, and the code will be running via cron job. It will be running it is basically listener code. It's already constantly listening to the traffic. So this is a flow chart, a simpler way of explaining the code. So the tools that we'll be using, we shall be using the AWS public cloud. We'll be using the CentOS OS, and the Docker Community Edition because it's free. The NetFilter kernel module is already a part of the Linux kernel. Some people might know it as IP tables, but it's the NetFilter kernel module. It's a default firewall in Linux systems. We'll be using load balancing using the NetFilter kernel module. So the check Nagios plugin utilities like phtop, iotop, and Ganglia. Ganglia is used for creating graphs. So these will be the last three would be used for creating benchmarks. You know, after we use the algorithm, we have to check our code with the existing algorithms to check if they are better or you know. So those are used for benchmarking. One thing I forgot to mention that our code would be written in Bash, which is the default shell in Linux, the born again shell. It's going to be a shell script. Cool. Thank you, thank you, folks. That's it. The proposal is given in detail in the proposal is given in detail in the research paper. Thank you so much.